So I think one important point to make here is if the goal of the DNS is that you can actually believe any one response of any one of these authoritative name servers, then that is based on the assumption that they are actually in sync. So for maintenance purposes like CDS processing, if you don't do the consistency check there, then that assumption is on shaky grounds whether they are actually in sync. So I would make an exception here and say if you are kind of establishing that things are configured consistently, then that's where you have to be extra careful. Do a consistency check, and then if that succeeds, then you don't need to do consistency checks later on other responses.
You're listening to Ping, a podcast by Fiebig discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking to Peter Thompson from Secure Systems Engineering and his own DNSSEC-enabled DNS provider company, DESEC. We've had Peter on Ping before, talking about a research project on post-quantum cryptography for DNSSEC. In this episode of Ping, Peter is discussing some inconsistencies that he has been measuring in the CDS space. CDS is a mechanism where a DNS zone provider with a child zone delegated below has to coordinate with that child over the updates to the DNSSEC keying materials, which secure the zone. The keys have to be signed over by the parent to maintain a secure chain of trust, but the keys have to vest inside the child's control and in their zone. The CDS and the CDNSKEY resource record is how this information can be communicated in band inside the DNS protocol between the child and parent. But there are opportunities for them to fall out of alignment between the various name servers of the child and with the parent. Peter has been measuring this and is working inside the IETF working group process to mitigate the problem. I caught up with Peter earlier in the year after seeing him present on this work in IETF 119 Brisbane. Peter, welcome to Ping.
Hello, George.
Before we start, can you just tell people a little bit about yourself? You're based in Berlin, is that right?
Yes, that's right. I've been in Berlin for about 10 years. So I've been doing internet stuff for about 20 years. It was initially next to my physics career, which I then decided to not further pursue. And so I started focusing more on internet and internet architecture. And a few years back, I started DESEC.io, which is a free managed DNS hosting platform with DNSSEC. And you can think of that like, let's encrypt for DNSSEC. Let's encrypt as free TLS certificates. We do free DNSSEC hosting. In that context, we think it's very important to attach the complexity of DNSSEC from the user and from the domain owner. And that's why it's so important to have automation. So that got me into automation, standardization work, and all of it.
So at IETF 119, you were in the DNSOP working group and you presented a really interesting talk there I saw on the measurement of CDS, CDNSKEY inconsistencies. And I think this is an important one that we kind of want to talk about and understand a bit better. So we're in the DNS and you are interested in DNSSEC. And there's this process that has to take place either in band or out of band to communicate keying information, cryptographic keying information, in order to create a chain of trust. Yes?
That's right, yes.
And there is a component of behavior here that is kind of bizarre. Trust has to come down from a trust anchor. So trust starts at the top.
Yes.
But signatures about zones and keys used by the delegate of a zone have to move upwards against the flow of the current in order to be signed by their parent.
That's correct, yes.
And your work in this measurement is in this space between child and parent, right?
That's correct, yes.
So, start at the beginning, take us through the story. What's going on here?
Okay. When a DNS operator who, for example, manages the zone example.com, when they decide, okay, let's create some keys and sign these DNS records in this zone, then they will be able to have the keys in it, and they will be able to have all the signatures for all the DNS records in that zone. And the client or a DNS resolver who then looks at that needs a way to figure out if the signature is valid. And how does it know what's the right validation key? So that's something that it should get from a point that it trusts. And the trust point is the parent, right? All the DNS resolvers have the trust anchor from the root zone provisioned within themselves. So the root zone can say, you trust us. And by the way, if you want to trust .com, then here is their cryptographic information. So that's called a trust chain. And so starting from the root, the resolver can infer how it would be able to validate signatures from, for example, .com. And then .com does the same.
Yeah. .com says, when we tell you about example, we're going to sign it using that key. And if you trusted that key because the trust anchor signed over it, you should trust things we sign over in example.
Exactly. So essentially, the parent endorses the validation key of the child. So .com endorses whatever key example.com uses. And then the question is, how does the parent .com know about what's the right key? So you have some kind of key exchange problem that you have to manage. That's where the CDS records come in. So this thing that the parent puts in for endorsement, that's called a DS record. It's just some crypto stuff, nothing to do with cryptocurrencies. So the CDS record is something on the child, which the DNS operator publishes and says, look, dear parent, this is what I want you to publish in the parent zone as the DS record so that I can establish this chain of trust.
And when we say publish, we mean in the DNS, because there was always the option to go out of band and use some out of band mechanism to do this. But I can't speak for anyone else here, but when I've tried to engage with different registries in order to upload my keying fragments, to have them legitimate them, sign over them and put them in their zone, it's an enormously painful mechanism, isn't it? It's just inconsistent.
It is quite painful. There's different ways of doing it, that's right. And as a domain owner, if you have to do it manually, you would have to know what's the right way to do it for your specific domain.
Yeah.
Depends on all kinds of things.
So an in-band mechanism, a signaling mechanism inside the DNS protocol is phenomenally attractive because it would get rid of that burden.
Exactly. So I'd like to cite a study. It's a few years old, and they looked at Cloudflare stuff. And at Cloudflare, you can turn on DNSSEC by ticking a box. And it turns out that 40% of those Cloudflare domain owners who do tick that box to enable DNSSEC, they actually don't successfully follow up in getting that DS record provisioned.
40%.
Yes, that tells you need some kind of automated workflow.
Yeah, there's got to be a better way of doing this. So CDS is a record in example.com in this instance, which is directed at .com to say, you need to know things about me.
Exactly. So there's always the problem, how does .com verify whether that CDS record was spoofed and maybe manipulated along the way? So when you already have an old key provisioned and .com already knows that, you can just use the old key to sign the new one and sign the CDS record. If you do it for the first time, though, you need some kind of bootstrapping method. So actually, one thing that we do at DESEC is develop standardization for that. It's called the DNSSEC bootstrapping protocol, and it is in the last phase of standardization. The IETF last call just ended, so it should become an RFC in a little bit.
There's quite a fertile conversation going on about the difference between pull protocols and push protocols and the applicability of generalized notify as a mechanism to signal to your parent. But that's kind of off to one side, right?
Yeah, that's right. So there are implementation details about that, yes.
Yeah. So you were doing a measurement exercise and you were actually looking at an aspect of this CDS, CDNSKEY data. So we probably have to bring other things to the table at this point in the DNS, the idea of an authoritative NS. Yes?
That's right. So the DNS is decentralized in the sense that for each domain name, a different name server can be responsible. Like you put the information about the key in the parent zone, you also put the information in the parent zone, which are the name servers that are responsible for example.com. So that's called a delegation. And so the .com parent domain could include the information that example.com is managed by, let's say, some provider's name server. And for resiliency reasons and stability, there's always more than one such name server, so it's at least two. And they serve independent copies of the example.com zone. And problems can appear if they start serving different CDS records, because then the parent doesn't know what's the right cryptographic DNSSEC stuff to actually provision. But of course, they will only notice if they do a consistency check on both name servers. If they just look at one of them and they just think, oh, that's fine, that's the child's DNSSEC information, and then proceed with configuring DNSSEC accordingly, things might go wrong.
So we've actually sort of seen this problem before, because the first thing is that people often assume, oh, one of these NSs is the real master, and it always makes sure that the other NS has a current copy. Well, life is not simple. And so there might be times when these machines are logistically disconnected and you can't guarantee that current data has come from a single point of authority. That's one problem. Another is that the DNS is a lot more complicated than people think. And it is possible for there to be methods of operation where these two entities are effectively independent and both think they perform critical signing functions. So the idea that there is one that is authoritative and the other one will always be in synchrony, it just doesn't apply, does it?
That's correct, yes. There is replication lag. You might be changing your key and one of your name servers somehow doesn't get the update, and then things get inconsistent. There are some other scenarios where things can be inconsistent and harm can be caused. For example, if you have a domain with two name servers and then the name server themselves, they have a name. It could be that domain name gets deleted from the DNS, the name server's domain name, because it expires. Maybe the DNS operator forgets to pay the bill for its domain name. And then somebody else can register that name server host name and kind of sneak themselves in.
Yeah, that's risky business, isn't it?
Exactly.
We've done a recording with Gautam talking about that. It is fascinating, the things that can go on there.
Right. Now, if you take over a name server like that, and then you put fake CDS records into the illegitimately served hijacked zone, then obviously you can go to some kind of escalation there and turn on DNSSEC and thereby kind of locking out the legitimate provider because they then wouldn't have the attacker's keys and would not be able to serve responses that validate, which is kind of a problem.
But the thing is, the DNS is not normally a space where you ask twice. If anybody gives you an answer, you tend to kind of go with the one you got first. So this behavior of checking for consistency is not a normal mode of operation, is it? This actually demanded that somebody do an experiment.
Yes, that's right. So I think one important point to make here is if the goal of the DNS is that you can actually believe any one response of any one of these authoritative name servers, then that is based on the assumption that they are actually in sync. So for maintenance purposes like CDS processing, if you don't do the consistency check there, then that assumption is on shaky grounds whether they are actually in sync. So I would make an exception here and say, if you are kind of establishing that things are configured consistently, then that's where you have to be extra careful. Do a consistency check, and then if that succeeds, then you don't need to do consistency checks later on other responses.
Yeah. So your presentation talked about research that was done by the Max Planck Institute. Steurer and Fiebig did a large collection. I think it was around 300 million records they collected.
That's correct, yes. They did a very comprehensive study and measured name server records and their IP addresses and CDS records of all of these zones that are served by these name servers as far as they are known, of course. I mean, there is no complete insight into the DNS, but as far as things could be discovered, they looked at it. It is a large amount of data, I believe 80 terabytes or something. It's also not a study that's done every week. It's more like a point-in-time thing. I think it was done around the change of the year.
Yeah.
And I learned about this recently at the ITF, and it turned out that they can analyze the data pretty quickly. And they hadn't looked at CDS inconsistencies before, but they did have the data available. So we decided, hey, let's have a look together and see if this fear of mess-ups through CDS consistency problems, if that's actually a thing, and how frequently it really happens.
I really like that quality of the retention of data that's collected for an objective primary purpose, but it turns out there are secondary or unrelated questions. That's a really lovely example of research cooperation, Peter. That's great.
Yeah, I mean, it's mainly on them, but yes, I love it too.
So tell us a bit about what you saw.
Yeah, so among these a few 100 million zones, we found 8.4 million zones that have CDS records, and there were also 1.3 million zones which had CDNSKEY records, which is very similar. So the CDNSKEY thing is a more basic presentation format, and you can compute CDS records from them. So I'll not go into the details. But
so the two sort of overlap in function. It's possible to have one, it's possible to have the other, it's possible to have both.
That's true. And it's also possible to have them inconsistent, right? And
so two forms of inconsistency. Right. But you said that it's a total of somewhere around 9 to 10 million out of 300 million. So it's not actually massive coverage of having DNSSEC in this mechanism at this stage, is it? It's a smaller percentage.
Yeah, it's like 3% or something. And I personally believe, as we discussed earlier, manual DS provisioning is a problem. So I think it would be great if more DNS operators decided to work in this direction to include automation. So if DNS operators decide to do more automation, obviously, if it's not done right, then we will see more outages and more misconfigurations, more problems. And that has happened often enough with DNSSEC. And I think it is time, before expanding the deployment of automation, that we make sure that what we are actually deploying does not lead to problems. And that's why the CDS consistency checks are so important to be done by parents who process these records.
So we have a research collection, 300 million assets, 50 terabytes of data, and you found around 10 million instances of CDS and CDNSKEY, which then would allow you to do the subsidiary check against the specific NSs to say, do they show consistency or inconsistency?
Exactly. So amongst this data set, we did find inconsistencies between name servers for a given domain in about 0.1% of cases. So that's 1 in 1,000. And you could say that's low. But on the other hand, it's thousands of domain names that are affected. And that's obviously not a percentage of breakage one should accept in infrastructure.
No, there's a secondary dimension we're not talking about here, which is about the frequency and utility of a name. If you just took a name at random and 1 in 1,000 is broken, then you could at some level say, okay, we're in 4 to 5 nines territory of correctness here. If that name happens to be Microsoft.com, that's really extremely bad. So the assumption this is a low error rate has to be set against the utility and frequency of reference to the zone in question, which is a different problem. I agree with you. 1 in 1,000 is not a level we should tolerate. So did you drill further and actually look into the nature of the inconsistencies?
Yes. So we did slice and dice that stuff and looked at whether there's any patterns, whether specific configurations occur more frequently. And so we found a few interesting things. One interesting thing was that there was a domain name under .ch, which is the Switzerland country code top-level domain. And it did have DNSSEC enabled. And actually, the 2 name servers that it had, or maybe it was 3 name servers, I don't remember. But the name servers that it had did serve inconsistent CDS records that referred to different keys. And only one of those keys was actually provisioned in the parent. So the DS record in the parent corresponded to the CDS record served by one name server, but not the other. So that means that it was kind of half set up. And .ch actually does process those CDS records. So what that means is that the records were processed, the parent happened to look only on one at the name servers and then used that. Now they do try to do some sanity checks. For example, they don't use it immediately. They'll check again the next day or something for 2-3 days to see whether things remain stable. But if you statistically happen to always look on the same name server, which can happen,
can,
then that happens. So this is a nice example that the problem actually does happen in practice at parents who do process these CDS records.
So we should stress at this point that in some sense, every single one of the actors in this situation were trying to do the right thing. And there was a procedural breakdown that exposed them to a risk of misalignment. But if you do the trivial checks, the simplistic form of checking to just say, does my parent have this record? As long as you got exactly the right NS looked up, and as long as the parent consistently checks that one source, it's going to say yes. Nothing is going to say to you, hey, your other NS is not flagging the same data. You would have to go the extra mile.
Exactly. I'm also not saying that .ch did do anything wrong, because the way the DNS has worked so far is that you ask one question, you get one response, and you use it. And the fact that they did look for several days is already an extra check that one could think would not be necessary. And I think it is kind of a new insight that the CDS inconsistency problem is actually a thing.
The thing that we've had previously has typically been SOA, stale SOA serial, and transitional changes in things like the names of name servers in and out of bailiwick so that you get multiple competing references to NSs. DNSSEC introduces this added complexity that all the other information you're publishing can actually be fully legitimate and correct, but the chain of trust depends on applying the right keys to perform cryptography checks. And so you can arrive at a point where nothing else is wrong, but the cryptographic processes say, I'm really sorry, there's a loss of integrity across this boundary.
Yes. So actually, the CDS RFC, which is the standards document for this kind of CDS record processing, it does say that the parent should make sure that when it acts upon the CDS record, that it doesn't break the delegation, right? So depending on how you do it, some failure modes like this one we're discussing are not obvious. So the standard does consider the problem, but in a very abstract way.
Yeah. Standards written before operational experience,
Exactly.
perhaps, so they hadn't exposed themselves to knowledge of the risk.
Right, exactly. So now we have a draft in the DNSOP working group of the ITF, which essentially tries to update this guidance and say, if you process this stuff, make sure to look at each of the name servers. And then there's, of course, like devils in the detail as usual. What happens if you can't reach one of the name servers and all of that stuff?
So this is the consistency is mandatory draft.
CDS consistency is mandatory, yeah.
Yeah. And it's reasonably early stage in some ways. It looks like it's around version 3 draft at this point, but it's not highly contentious work, is it? This is very likely to be a fairly smooth passage.
So I won't look into the future. As far as I know, there are no implementations of this. I hope that the measurements that we've done and where we have exposed actual instances of the problem in the wild will help convince people that this is something that would be helpful to do. At least during the discussion at ITF, there wasn't much pushback by anyone, but obviously running code is paramount. So let's see where it goes.
So that's going to be an interesting step to get to, but perhaps we can come back to that later. So you found that situation, but there are actually more reasons why there might be a failure here. It might not just be that two NSs serve conflicting statements about cryptography as a function of an incomplete key rollover or an algorithm change or a lack of phasing and update between them. It's possible that one of them actually doesn't even know that it has to serve this data. So in your slide pack, you actually talk about cross-NS consistencies is potentially because of one of the NSs serving empty data.
Oh, yeah. So the most frequent example of these CDS inconsistencies is actually when one name server does respond with a CDS record that has some kind of content, and another one thinks, oh, there is no CDS record and serves an empty response. So this might be not a problem if that name server has all the other signatures and keys and all of that to later on when the key is used to actually serve signed responses. But the point is that the parent, when it observes this, it can't know whether that's the case or whether, for example, this is a multi-provider setup where one provider is using DNSSEC and the other one isn't.
Right.
So there's different kinds of failure modes. Another one that looks exactly the same would be, for example, if you are in the process of transitioning to a different provider. Let's say you have your domain with a DNS provider that doesn't do DNSSEC. You would like to do DNSSEC, so you transition it. You can do that with a phase where you have the old and the new NS records in the delegation, so some queries will reach the old and the new provider. And if the new one, which uses DNSSEC, already has deployed their CDS records, then you are in exactly the situation that some name servers serve CDS records and others don't, and it would not be safe to act upon them.
So you did mention that although this record is something that could be updated almost instantly using online dynamic DNS update under signature, the parent is not expected to react immediately to change. The parent's actually meant to hold and to review and to check and to consider consistency over a longer baseline.
That's what I think and what the authors of the draft think would be the way to handle this in a reliable and safe manner, yes.
Can you give me more examples of the kinds of failure you saw in this data?
So we find that about half of the CDS inconsistencies are actually a dual setup of Google hosting and Wix DNS, which is a managed provider for like making a website on some web interface.
So when you say dual hosting, dual provider, there's a component of work here that is purely in the web service provisioning, but there's also the join of DNS services and DNS infrastructure. Which part of the pie are they sharing?
So we don't know exactly what the genesis of these configurations is, but the way it looks usually is that name server records are provisioned both for Google name servers and for Wix DNS name servers. So this could happen, for example, if the customer originally purchased the domain from Google, and maybe then it is set up by default with Google name servers, and then they perhaps decide, okay, I want to use the Wix DNS web service, and they have to do an NS update in their delegation. And then perhaps in the transition phase, something goes wrong, or maybe it is the normal state of things and it's just taking some time so that there is a dual setup for a while. So we do find that about half of the inconsistencies are of that kind of type. And both Google and Wix DNS do publish CDS records, and they are not consistent, obviously, because they have different key material. Then, of course, a parent should hold off acting upon that and not provision one of them and not the other.
It's quite interesting here that Google is providing services, including DNSSEC enabled functionality, but has made a decision in regard to their own google.com domain to stay away from this surface. That's something Jeff Houston has been looking at, and he notes that there is a sort of weird dichotomy. People are providing services in DNSSEC. It doesn't necessarily mean that they use it behind their own namespace. It's an interesting distinction that has to be drawn.
Yeah, I do agree. So I think one reason for that could be that when you have a new domain name, like a customer registers a name, and you turn DNSSEC on, there is actually nothing that breaks at the time because it's not in use yet. While if you already have a domain that's in heavy use, like google.com, there is a much higher cost when something goes wrong in that process. And when you need to roll back, the question how quickly you can do that depends mostly on the TTL of the DS record that the parent publishes. And that's not on the scale of minutes.
TTL being time to live, which is an attribute in the DNS that flows along with the message. So if you're not in DNS space, it's very like TTL in other network contexts, except this one is a long number. It can be days or months even of time that you're told this record is valid.
Right. So DNS resolvers or clients might use that value as long as the TTL indicates. And so if you provisioned DNSSEC with a TTL value of, let's say, 1 day for the DS record, and you learned right after doing that, oh shit, I messed it up and I don't know, wrong key or something, then roll back.
Some random amount of the internet is never going to bother resolving the new state because as far as they're concerned, you said the old one was good for a day.
Right, exactly. So I think, I'm not Google, but I think one thing that would make a difference for such heavily used domain names is if the TTL value for DS records in zones like .com would be a lot lower, and that wouldn't have to be the case for all DS records. It would be sufficient to set a lower TTL value for some time after there is a change, right? So that when there is a change, that change is not inscribed for a day or something, and you can roll back more quickly, let's say 5 minutes or whatever. And probably that wouldn't cause a lot of load. The parent would get more questions about the DS record because it has to be re-asked more frequently when it is valid for a shorter time. But people don't change the DS records very often. So it only would affect a few domains of all of them every day, right? So it seems to me that more discussions need to happen in that direction if we are trying to get large companies like Google into the boat of using DNSSEC for their own domain name.
So you have an example of this happening with Wix DNS and Google domains, but the thing is, you actually can see this happening in other combinations of provider. If you have a dual provider role exposed in your name service, it seems like that's a potential foot gun that can cause this problem to emerge.
Right.
And you also noted that there was no necessity for this to be multi-signer. So one of the main complexities that people see emerging is sign on the edge and the idea of having an intermediary that's performing signing on your behalf in order to get things out there, which of course is an added complexity. But you didn't see a strong signal that's the root cause of this kind of inconsistency.
Not really, no. That doesn't mean that that doesn't happen, but there's only so much you can see in the data, right? So another interesting instance, and I don't know if it is related to edge signing, there was one domain under .com where all name servers were operated by Google. I think it was 4 name servers, all Google domains. Mm-hmm. And they also did serve inconsistent CDS records. Now, I don't know what kind of misconfiguration that is. Maybe it is a misconfiguration done by the domain owner. Maybe it is a misconfiguration done by Google with replication out of sync, or maybe it's something entirely different. So the point is that even within one DNS operator, that problem can occur, even if that's a very large company. I think for considering checks at the parent, what should the parent do in order to deploy DNS records? I think it doesn't really matter what the cause is for an inconsistency. As long as you are able to detect the inconsistency, you should not proceed because it is not safe. And it would be great if the parent had a way to notify the DNS operator and say, hey, we didn't process your record because it was inconsistent. And by the way, you might want to look at it.
So in summation, there's a value that has to exist, and there's a potential for drift in the value between your authoritative NSs and in communication with your parent for them to read this label and infer from it structural behaviors they then have to represent signing over your domains. And although it doesn't exist in a scale that is 5 or 10%, it exists in sufficient scale that if DNSSEC continues to propagate, we are going to see literally hundreds of thousands of domains that are exposed to this inconsistency risk, which means there'll be functionally loss of secure state between parent and child for some people being resolved. And it's kind of irritating. It shouldn't be like this. We should work harder to get rid of it. That seems to be where we've gone to. And you've written a draft that says, well, we should try harder to eliminate this problem.
I totally agree. I think one point that is often overlooked is, well, I think people have it in their minds in one way, which is, DNSSEC is complicated. It's easy to make mistakes. And so the image of it is not the best of DNSSEC. But I think that's one more reason to make sure that we don't completely ruin the DNSSEC image by allowing for failure modes that we actually know how to fix.
Yeah.
So I think it would be very, very bad impact if we did know, these inconsistencies can happen. Then we roll out bad automation for millions of zones. Then things break and everybody's like, DNSSEC is bad.
This does now come to the sort of secondary point that we haven't touched on, which is this is implicitly a polling mechanism. This demands that the parent perform polling to query children and say, what's the state of your CDS, CDNSKEY records?
That's right. So whenever the parent has reason to act upon CDS records through some notification, or because it looks according to some kind of schedule, or because somebody pressed some button, the process that should be triggered then is a process where the parent proactively goes ahead and fetches the information from the different name servers that are responsible for the child zone and tries to make sense of it.
So we've gone from a world where notify was essentially how authorities told their siblings you should get a refreshed state of the zone, to the emergence of the idea of generalized notify, which opens up the potential of children using notify as a signaling mechanism to parent. So I could see future potential if we change signaling barriers here, that a parent is told more frequently and more directly a CDS change has happened. And in some senses, it actually increases the burden on them to perform these checks. If they're going to be told you should do something, they should also be told you should do it properly.
Yes, I agree. So this is actually the content of another draft, which is, as you mentioned, the generalized notifications draft. And it uses the existing format of DNS notify messages that are used for secondary name server synchronization. There's usually primary, updates are made to the primary, and then the primary distributes it to the secondaries, and the secondaries fetch the zone upon receiving such a notification from the primary. And so the draft about generalized notifications reuses this not to talk to its siblings, secondary name servers, but to talk to the parent actor, which is the registry or the registrar, and have them perform whatever is necessary to do a DS update. And that entails doing all these CDS consistency checks.
So if we agree that a 0.1% failure rate is there, is this actually something that is maybe going to be rechecked? Do you feel like there might be a second run to see the dynamics of this figure? You're saying it's not an everyday test, but it would be interesting to perhaps think about a resampling or another cohort.
Yes. So what Tobias and Florian, who are the two researchers, told me is that they are planning to recollect the data, but not very frequently. So it perhaps could be done once a year or twice a year or something, but I cannot speak for them. The only thing I know is that it was not meant as a one-shot project. So I think before the measurement would be redone, they, I guess, would first do more deep analysis of what they have And then once that's exhausted, update the data.
Peter, is there anywhere people could go and read about this problem and other aspects of it?
Yes, of course, apart from the IETF slide deck that is publicly available, and perhaps you can put a link.
Yeah, I'll do that.
There is also an IPNIC blog article about the DNSSEC bootstrapping problem. How do you establish trust to the DNS operator's key initially? If you're the parent, how do you know?
Oh, that's the piece written by Nils Wiziol, yes?
That's right. Yeah, he's actually my colleague. Both he and I are authors on the corresponding IETF draft. And that's another piece of the problem space that is worth looking at.
Oh, great. Well, we'll put a link to that into the blog then. Thanks.
Thank you very much.
Yeah, we need to work harder to clean these corner cases up, basically. And I really look forward to some resolution of this problem. Peter, it's been absolutely fascinating. Thank you for coming on Ping and talking about it.
Thank you very much for having me.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember the measurement@apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time,